In this video, we're going to talk about how to see into a fault or see into a rock unit. Now, you can do that through trenching if you were doing this in the field. So when we talk about this, you can also think about this as how you would orient your trench so that you're best seeing into the rock. Now, if we were going to make a cross section, then you might already know the answer. So let's say we've got a fold going on over here. A, B, C, these different units. And let's say that I collected some dip information in the field on these different units. Okay, if that's the dip information I have, then you might already know that the best cross-section line, the one you would want to make, is going to go the most perpendicular to the strikes of those strike and dips that you've collected, of those points of data. And the reason for that is that when we would go to make our cross-section line, we have to deal with a parent dip. And the closer your strike is to being perpendicular to your cross-section line, the closer your apparent dip is to your true dip. That's because that calculation for apparent dip incorporates whatever the acute angle is between the strike of your data point and the strike of your cross-section line. So the closer that is to 90, the more your apparent dip and your true dip are going to be the same value. So when in doubt, the best answer is going to be perpendicular to structure. Okay, so let's see if that holds for fault types as well. All right. So the first fault that I'm going to start with, let's just imagine a normal fault. Ooh, this joker ended up being bigger than I thought I was going to draw in. It's all right. Okay, so I've got a normal fault, and I'm going to give myself some units to keep track of. And, oh man, I do this as a thrust. I'm sorry, guys. This is absolutely not a normal fault. This is definitely a thrust fault. Oh, I'm having a day. I drew it steep. It's probably what messed with me. I'm gonna carry this down. Okay, so I've got these two rock units, this one rock unit, this green unit, and it's offset across this fault plane. And I know that this is a thrust because I've moved my hanging wall up relative to my football. If you were yelling at me a second ago when I called it a normal fault, you can join my inner voices. Okay, so I've got my hanging wall block up above my footwall, and I'm going to imagine cutting into this fault plane. Now, if I cut, let's say I'm going to cut a vertical trench. If I cut my vertical trench, or I imagine my slice happening parallel to the fault, cut straight down, parallel to this fault. Now, I'm not actually going to see any of that fault, right? If I cut parallel to the fault and I cut straight down, what I'm actually going to get is a slice through my football. So I would open this up, open it up along that cut. And what I am going to see is at the top, I'm going to see my fault trace. And then midway down through my trench, I'm going to see my green unit. And that's it. I'm not actually going to get a good idea of what my offset is. So now let's pretend that we trench perpendicular to the fault instead. Okay, I'm going to imagine that kind of erosion has happened so that I can cut straight down through here. Actually, let's draw it in the middle of our fault section. Okay, so I know this is a little cluttered. If I were looking at this in bird's eye view, let's say that my fault is trending north. I'll just make it easier to draw it on here. Let's say that's my fault. In bird's eye view, where I've just imagined making this cut is right across here. Okay, so now let's dive into the subsurface. So in this situation, I've made my cut. I am gonna drop down. I'll actually see my fault cutting through my section. So at the surface, it's just a point, but I'm actually getting a chance to see it come down and dipping through that unit. And then I can see the green unit. In the hanging wall, it's going to be a little bit higher, and in the foot wall, it's going to be a little bit lower. And so in this situation, assuming that this thrust was not oblique slip, it's a perfectly dip slip thrust, then I have the opportunity to measure my true displacement along that fault. So that's pretty fun. We can imagine the exact same thing happening in reverse with a normal fault. Again, if I were to do this with a normal fault, I'm going to get that best view if I'm going perpendicular to the strike of my fault. Now, how would that be different in a strike slip situation? Let's draw a couple different strike slip faults. Okay. Now, I might imagine this two different ways. Okay. Same thing over again. I could imagine this with horizontally oriented stratigraphy, or I could imagine it with dipping stratigraphy. Most of the time, I think our units are going to be dipping just a little bit. Okay, if I have horizontal stratigraphy and I'm dealing with a strike slip fault, then I'm kind of kind of in trouble. I'm not actually going to be able to see that offset. If I go parallel to my fault, I'm not going to see the offset. I'm just going to see the one plane of rock. So parallel to my fault, if I cut right along my fault line, I have horizontal units and I have a horizontal fault trace at the surface. And if I cut perpendicular to my fault, okay, I've gone across. Well, now I don't see anything either necessarily. That's assuming that this is like in a perfect world. Now, really, along a strike slip fault, you're going to have some grinding. You might have some material pushed up right here in the middle. You'll have a damage zone. And so I would still go perpendicular to the fault in that scenario, even though you're not necessarily going to get any kind of vertical offset in the rock units. But that choice becomes really exaggerated when we have dipping rock units. So let's look at why that is. If I cut straight across, and I'm gonna draw in a few more dipping strata here. Let's give ourselves a double red. If I go straight across my fault, and let's say that I maybe don't have this much offset because this is going to make things kind of tough. I'll go right here. Okay. And let's say that I know my stratigraphy pretty well, then I might hit that red rock unit on this side over here and hit my green one over here. So by doing that, I can see that there's a difference, and if I knew how these rocks were dipping, then there is a mechanism for me to find the full displacement on that fault. Just have to kind of visualize it out like this. So if I took a slice right through, I would be able to see those differences in the green unit and the red unit. And actually here, I think my green unit would be up higher, it wouldn't be down lower, relative to that red unit. So would look a little bit higher than it should be. And that would be my signal that I've had some strike slip motion. All right. Thank you for visualizing faults with me. I hope it was fun. Bye.